Hi everyone, it is Mrs. Coates here again with another maths challenge, and once again we're inspired by the work of Steve Wyborney, who can be found on Twitter at Steve Wyborney if you fancy a little follow of his work. So these tasks are to do with calculating the area of a tiled area shape if the square is equal to 1. Just a wee hint, some coloured pencils, pens or crayons might come in really handy. Take a look at this picture. If the area of the square in the bottom left is equal to 1, what is the area of the entire shape in the middle of the screen? Pause this video and see if you can have a think about how you might approach this task. Could you explain it to someone else? I started by colouring in all the complete squares that were valued at 1 that I could see. So right in this image just now there are 2, so I coloured them in pink. Then I had to think about the shapes that were left, and I noticed that the bottom square, the smaller one, if I was to add that to the shape in the top left that I've just coloured in blue, that would be the same size as the larger square that was equal to 1. So I have 2 pink squares, and altogether I've got what makes up 1 blue square. That's 2 add 1, so altogether that's 3. So I think the area of this tiled shape might be 3. I then thought about other ways that I could prove to someone else that the area of this shape was 3. Would they be convinced? I remembered that the smaller square, well, 4 of them was equal to one of the larger squares, so I then divided the rest of the shape up into the size of the smaller square. I knew that 4 of them would equal 1. So I started by colouring in 4 of them pink, because then that gives me 1. I then coloured in a second group of 4 blue, and I coloured in the final group of 4 green. I knew that I had 3 groups of 4, so that would mean that the value of this tiled area shape was 3. Have a go yourself and see if there are any other ways that you can prove that the area of this tiled shape is 3, and try some of the other ones coming up. Can you prove those by using different ways as well? What if the value of the square was different? What if it wasn't worth 1 and it was worth something else entirely? There's loads of ways that you can generate numbers for this little challenge. You could use numbers from outside of a domino, add the dominoes together, roll a dice, choose a random number you see around you, or choose or make up a number of your own. You could even choose a decimal number or a fraction. The sky really is the limit. But have a think. Do they always work easily, or does it help if it's a particular multiple of a number or can be divided by a particular number? I wonder why this might be. Have a think. Could it be to do with the fraction of the squares visible in the way that these images are arranged? You'll notice that the squares that are visible, or the shapes that are visible, are a fraction of the square. What fraction are they, and what does this tell you about the numbers that we might be able to work with? Have a go. Can you create some of your own as well for others to try? As always, make sure to use the hashtag TeamMenMaths to share any of your working with us, or if you want, email Mr. Gray using the email on the screen with your solutions or with the challenges that you've created on your own. Have fun!